Good evening. We start with sum number 4. Use binomial theorem to evaluate the following up to 4 places of decimals. Again, this type is important. Let us discuss first one, root of 99, that is 99 raised to half. 99 is to be written as 100 minus 1. Okay. Now, within bracket take 100 common. So 100 into in bracket 1 minus 1 upon 100 raised to half. 100 raised to half, that is 10. Expand this using 1 plus x raised to n. What is that? 1 plus nx plus n into n minus 1 upon 2 factorial x square. Right? We have to write one more term because answer up to 4 places of decimals is required. So this is 10 into 0.9949875. So 9.9499 is the answer, correct up to 4 places of decimals. Second is cube root of 126. Cube root means raised to 1 upon 3. Now 126 can be written as 120 plus 6, 127 minus 1. But we have to write 126 as what? 125 plus 1. Why this is so? Because cube root of 125 is 5. That is why. So within bracket, take 125 common to get this. 125 raised to 1 by 3 is 5. Now 1 plus x raised to n is 1 plus nx plus n into n minus 1 upon 2 factorial into square of this. Clearly, this is too small to be taken into consideration. Why? Because we are asked to find answer up to 4 decimal places. Now what I have done is, what is 1 upon 125? Multiply numerator and denominator by 8. So 8 upon 1000, that is 0.008. And if you divide it by 3, you get this. So 5 into 1.00266, I think 5.0133 is the answer, correct up to 4 decimal places. Third part, fourth root of 16.08 means 16.08 raised to 1 by 4. Now 16.08 is 16 plus 0.008. Within bracket take 16 common. Fourth root of 16, 2. Now expand this using 1 plus x raised to n. So that is what? 1 plus nx. No need to consider the next term. It is too small to be taken into consideration as we are asked to find answer correct up to 4 decimal places. Now I have written 0.005 for this. Now again divided by 4 to get 0.00125. So 2.0025 is the final answer. Now we discuss binomial coefficients. See the coefficients NC0, NC1, NC2 up to NCn in the expansion of a plus b raised to n are called the binomial coefficients of order n. Why order n? Because the index is n. Now they are not independent. There is some relation between them. Let us try to find the relation between these binomial coefficients. Actually, we are going to prove 2 important results. We are going to call NC0, NC2, NC4 as even binomial coefficients. Then NC1, NC3, NC5 as odd binomial coefficients. Actually, if we are considering binomial coefficients of order n, then we can drop this prefix. This is called as prefix n, and we can just say C0 plus or C0, C2, C4 are even, and C1, C3, C5 are odd binomial coefficients. Now the first and the most important result is sum of sum of all binomial coefficients of order n. Sum of all binomial coefficients of order n is 2 raised to n. This is very interesting result. I repeat, sum of all binomial coefficients of order n is 2 raised to n. We are going to discuss the proof also. Proof can be asked in exam. Now can you express the second part in words? C0 plus C2 plus C4 plus dot 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 equal to C1 plus C3 plus C5 plus dot 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 equal to 2 raised to n minus 1. Yes, that's it. Sum of binomial coefficients or sum of even binomial coefficients equal to sum of odd binomial coefficients, and each sum is 2 raised to n minus 1. I repeat, sum of even binomial coefficients equal to sum of odd binomial coefficients, and each sum is nothing but what? 2 raised to n minus 1. Let us prove both the results. Can you tell me what is 1 plus x raised to n? It is nc0 or just c0, right? nc0 plus nc1 into x. See, when I say of order n, clearly n is a natural number. I know that uh, previously we discussed binomial theorem for any real index, but when I say binomial coefficients of order n, by that I mean n is a natural number. So what is 1 plus x raised to n? It is nc0 1 raised to n, but I haven't written that, plus nc1. Again, I'm not writing 1 raised to because it is 1. So simply nc1x plus nc2 x square plus nc3 x cube up to what? Up to ncn x raised to n. This is not at all difficult. We have used the basic binomial theorem for natural index 1 plus x raised to n equal to. Okay. Now, in this result, put x equal to 1 because this is true for all real values of x. So I say put x equal to 1. I will write right hand side first. So it is nc0, right? nc0 plus nc1 into 1 because I have put x equal to 1. So nc1 plus nc2 into 1 square, that is 1. So only nc2 plus nc3 up to what? Up to ncn. And put 1 x equal to 1 in LHS. So 1 plus 1, that is 2. So 2 raised to n. Yes. So sum of binomial coefficients of order n is always 2 raised to n. So if index is 10, 2 raised to 10, that is 1024. I hope you understood this. Now how to prove the second part? Simple. Put x equal to minus 1 in the same result. This is binomial theorem. Put x equal to minus 1, right? Therefore, Therefore, I can say 1 minus 1. Consider LHS first. What is 1 minus 1? 0. So 0 raised to n, that is 0. Plus rather equal to NC0 plus NC1 into minus 1. So NC0 minus NC1 plus NC2. Why? Though x is minus 1 square is plus 1. So plus NC2. Okay, minus nc3. Why? Because minus 1 cube is minus 1, and so on. Expected next term is nc4 minus nc5 and so on. You will notice that odd binomial coefficients are negative. Bring them to LHS so that I can say nc1 plus nc3 plus nc5 equal to what? nc0 plus nc2 plus nc4. So we have proved what? That sum of odd binomial coefficients is the same as sum of even binomial coefficients. Suppose each sum is nothing but k, because we have to prove that each sum is basically 2 raised to n minus 1. But at present, I just know that these are equal and let each sum be k. Now use common sense. Consider this result. This result tells us that sum of all binomial coefficients is 2 raised to n. I divide left hand side into two parts. Which two parts? First part, sum of odd binomial coefficients. What is that sum? K. We have assumed that the sum is k, plus sum of even binomial coefficients. That is also k. So k plus k is 2 raised to n. That is 2k. is 2 raised to n, but we are interested in k. Okay, so that gives me k equal to 2 raised to n upon 2. So as per laws of indices, it is 2 raised to n minus 1. And therefore, sum of odd binomial coefficients equal to sum of even binomial coefficients equal to 2 raised to n minus 1. Now exercise 4.5, first sum, show that C0 plus C1 plus C2 up to C8 is 256. Simple one. You can use this as standard result. But if this sum is asked for say 3 marks, then first you have to prove that sum of all binomial coefficients of order n is 2 raised to n. But here you need not. So write this. Now what is asked? C0 plus C1 up to C8. So you have to put n equal to 8. 2 raised to 8 is 256. Okay. Second, for homework, actually, okay, we'll be doing third sum. The third one, show that C1 plus C2 plus C3 up to C7 is 127. Now, sum of binomial coefficients of order 7 is 2 raised to 7, that is 128. But it includes C0 also. But we are asked to find C1 plus C2 up to C7. So it is 128 less C0. C0 is nothing but 1. So 128 minus 1. So 127 is the answer. Sum number 5, show that C0 plus C2 plus C4 plus C6 plus C8 equal to C1 plus C3 plus C5 plus C7 equal to 128. Now we begin with sum of binomial coefficients of order n is 2 raised to n. Here order is 8, so 2 raised to 8, that is 256. Now left hand side can be written as what? C0 plus C2 up to C8, that is sum of even binomial coefficients plus sum of odd binomial coefficients, but each sum is the same. Let each sum be k, so that left hand side is actually k plus k, that is 2k equal to 256. So what is k? 128. So sum of binomial coefficients with even suffixes is the same as sum of binomial coefficients with odd suffixes, and each sum is 128. Now for sum number 7, we require this actually. Uh, 1 plus n minus 1 plus n minus 1 into n minus 2 upon 2 factorial plus dot 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 up to 1, rather plus 1 is what? Can I write this 1 as n minus 1 C0? Yes. Can I write n minus 1 as n minus 1 C1? Yes. Can I write this as n minus 1 C2? Yes. And last one is n minus 1 Cn minus 1. So this has become sum of binomial coefficients of order n minus 1. So the total will be 2 raised to n minus 1. We have to use this in sum number 7. So the sum is, show that C0 plus 2C1 plus 3C2 plus 4C3 plus n plus 1 Cn equal to what? N plus 2 into 2 raised to n minus 1. Let me explain first. So C0 plus 2C1 and so on. Now I write this as C0. What is 2C1? It is C1 plus C1. Simple. What is 3C2? C2 plus 2C2 and so on. Now I know that sum of all binomial coefficients of order n is 2 raised to n. So I write this as C0 plus C1 up to Cn. In the next step, you can see that it is replaced by 2 raised to n. Now what is left is put in another bracket. See, originally there are 2 C1 of which only 1 C1 is considered, and that is why 1 C1 is left, 2 C2 are left, 3 C3 are left, up to what? NCN. I hope you understood this. So we have write the same in different form. Now next part is interesting. See, C1 is basically NC1 because we drop the prefix. So here I have written the prefix NC1 and so on. But what is NC1? NC1 is nothing but n plus 2. What is NC2? It is n into n minus 1 upon 2 factorial. This is not at all difficult. We have done this. Plus 3 into, what is NC3? N into n minus 1 into n minus 2 upon 3 factorial up to n into NCn, that is 1. Next step is take n common from all these terms. There is plus sign. So from each term you have to take n common. So when n is taken common, we get what? 1 plus n minus 1. Now you will ask me, sir, what about this? 2 factorial is 2, gets cancelled with this, right? So just n minus 1. Then n minus 1, n minus 2. Previously it was 3 factorial, I agree. But 3 factorial is 2 factorial into 3. So this 3 gets cancelled. So 2 factorial up to 1. In fact, I have written this only. See, 2 raised to n minus 1 for this. I can show you. See, 1 plus n minus 1 up to this. We have written 2 raised to n minus 1 for this. Okay. But originally n is there. So n into 2 raised to n minus 1. Next step. This 2 raised to n is written as what? 2 into 2 raised to n minus 1. Laws of indices. Now why to write like this? Because we have to take 2 raised to n minus 1 common. Simple. Some students will say, sir, why to waste time? Just say taking 2 raised to n minus 1 common. Yes, that is also correct. So when I take 2 raised to n minus 1 common, what remains in bracket is 2 plus n, that is n plus 2. Hence the result. Now we will be discussing miscellaneous exercise 4. First sum, select the correct answer from the given alternatives, that is we'll be solving MCQs. First one, the total number of terms in the expansion of x plus y raised to 100 plus x minus y raised to 100 after simplification is, this is interesting. See, clearly there are 101 terms in the expansion. So for x plus y raised to 100, all terms are positive. And for x minus y raised to 100, first is positive, second is negative. Means even number terms are negative. So last term will be positive. Now they are to be added. So when addition is done, this gets cancelled, right? This means even number terms get cancelled. So odd number terms, they only remain. It is true that each term occurs twice, right? But when I say, suppose the term is x raised to 100, x raised to 100 plus x raised to 100, these are not two different terms. These are like terms. I can say that it is 2 into x raised to 100, simple. And therefore, there are how many terms? 51. So what is the correct option? The correct option is B, Bombay. I hope you understood this. Don't say that we will expand this, we will write 101 terms. You have to solve this in 108 seconds, not 108 hours or minutes, right? So B, Bombay is the correct option. Second one, the middle term in the expansion of 1 plus x raised to 2n will be. Obviously, there are 2n plus 1 terms. So number of terms is odd. So the middle term is tn plus 1 because n terms are before this and n terms are after this term, right? So the correct option is C, Calcutta for second one. Yes. Now, what about sum number 3? In the expansion of x square minus 2x raised to 10, the coefficient of x raised to 16 is. Let us find general term in the expansion. What is that? TR plus 1. It is 10 CR. Okay. First term is x square. So x square raised to 10 minus r into minus 2x raised to r. So this is 10 CR minus 2 raised to r, x raised to, I am writing this directly, a raised to m raised to n, a raised to mn. So x raised to 20 minus 2r plus r, right? Now for this term to be in what? X raised to 16. For term in x raised to 16, 20 minus 2r plus r equal to 16. So tell me what is r? R is 4. Now what is asked? Coefficient. Therefore, coefficient is nothing but 10c4 minus 2 raised to 4. Tell me the value of 10c4. 10c4 is 10 factorial upon 6 factorial 4 factorial. So 7, 8, 9, 10 upon 24. And what is 2 raised to 4 minus 2 raised to 4? It is 16. Yes, so this will be 210 into 16, which is 3360. Is this given? Yes. 3360. It is given in option C. So C, Calcutta is the correct option. Third sum, in the expansion of x square minus 2x raised to 10, the coefficient of x raised to 16 is. Now this is the general term tr plus 1, right? Minus 2 raised to r is part of coefficient. We must obtain single term in x because we have to equate its index with 16 as we want a term in x raised to 16. So it is 20 minus 2r plus r equal to 16. So r equal to 4. So what is the coefficient? 10c4, which is 210 minus 2 raised to 4 is 16, 3360. So the correct option is C, Calcutta. Fourth one is good one. The term not containing x in the expansion of means what? Constant term. That is term in x raised to 0. But remember, it is 1 minus x bracket square into x plus 1 upon x raised to 10. Right? Now, let us find 1 minus x bracket square. So it is 1 minus 2x plus x square. This is to be multiplied by x plus 1 upon x raised to 10. See, we want a constant term. So when we open the bracket, 1 into which term will give you constant term? 1 itself is a constant. So term in x raised to 0. So we are interested in term in x raised to 0 in the expansion of what? Second part, x plus 1 upon x raised to 10. Now when x is multiplied by x raised to minus 1, that is 1 upon x, that gives you a constant term. X square should be multiplied by a term in 1 upon x square, that is x raised to minus 2. So these three will give constant terms in the expansion. Okay. So let us find general term in the expansion of x plus 1 upon x raised to 10. It is tr plus 1 equal to 10cr, x raised to 10 minus r, 1 upon x raised to r. That is 10cr, x raised to 10 minus r, 1 upon x raised to r is what? X raised to minus r. That is why I have directly written 10 minus 2r as the index. Now, in x raised to 0, equate 10 minus 2r with 0. So r equal to 5. So that term is 10c5. Simple. Then we need a term in 1 upon x, that is x raised to minus 1. For that, I have to equate index with minus 1. That gives me r equal to 11 by 2. Absurd. Right? So if you expand everything, if you simplify, you will notice that the product does not give us a constant term. Now there is one more possibility. Term in x raised to minus 2. Is it possible? Yes, it is possible for r equal to 6. So for that we get 10c6. So what is the required term? 10c6 plus 10c5. Now ncr plus ncr minus 1 is n plus 1 cr, that is 11c6, but this option is not given. But you should know that ncr is ncr minus 1. I'm sorry, ncn minus r. So 11 minus 6, that is 5. Yes, this option is given. So the correct option is A, Ahmedabad. Right. Fifth one, the number of terms in the expansion of 4y plus x raised to 8 minus 4y minus x raised to 8 is, see, the base is 4y plus x in the first and in the second 4y minus x. That is why it is possible to guess. Okay. Now 4y plus x raised to 8. So in fact, I'm sorry, index is 8, right? So there are how many? 9 terms in the expansion. There are 9 terms in the expansion. Okay. Now there is minus sign in between. So first, third, fifth, seventh and ninth, these 5 terms get cancelled. So second, fourth, sixth, eighth, these 4 terms remain. So how many terms in the expansion? 4. So correct option is A, Ahmedabad, for sum number 5. Sum number 6, the value of 14C1 plus 14C3 plus 14C5 up to 14C11 is, see, sum of all odd binomial coefficients is always 2 raised to n minus 1. So I have listed all odd binomial coefficients. Now order is 14. So 2 raised to 14 minus 1, but that is 2 raised to 13. But we are asked to find sum up to 14C11. And that is why I have shifted 14C13 to right hand side. So what is the answer? 2 raised to 13 minus 14C13. But NCR is n minus R. 14 minus 13, that is 1. Now there are 14 things. We have to select only one. So selection can be done in how many times? 14. So 14C1 is 14. This is the final answer. So correct option is D, Delhi. Sum number 7 is similar. See, order is 11 and even binomial coefficients are considered. So 11C0 plus 11C2 up to 11C10 is 2 raised to 11 minus 1, that is 2 raised to 10. So what is 11C2 plus 11C4 up to 11C8? It will be 2 raised to 10 minus 11C0 minus 11C10. But 11C0 is 1. And what is 11C10? It is 11C1, which is 11. So 2 raised to 10 minus 12 is the answer, which is given in option D. So we'll solve remaining 3 MCQs and other sums in the next lecture.